Okay, so today's question is, what is the mechanism that causes coronal holes to be the source of high-speed solar wind? And this is a really easy question to answer, at least from the mainstream, in air quotes, point of view. So on the sun, we have magnetic fields, right? In some areas of the sun, these magnetic fields connect 2 points on the surface of the sun. So they're sort of like, just wrapping the sun itself in themselves, so to speak. But in some areas, these magnetic field lines are open, what they call. I mean, they have to close somewhere. They just don't close on the sun like immediately right here, right? So they probably go somewhere out to the edge of the heliosphere and then close like this, I assume. I don't really know. That's a question which is actually very difficult to answer, and perhaps nobody knows the answer yet. But the point is that at the scales of, let's say, 1 astronomical unit, they are open, all right? They appear so at the very least. So when the magnetic field lines just leave the sun like this, as I've told you in some of the previous segments, plasma, like the conductivity along the magnetic field line is much higher, and therefore particles can just freely move towards the Earth in this case, along this magnetic field line. And that's it. That's why you get the faster wind from there, because there isn't much preventing it from going towards the Earth. So the slower wind originates apparently from everywhere else. There is still a good question. I don't I know it's not part of today's discussion, but there is a good question of what accelerates the solar wind in the first place, and I'm not sure I want to talk about this, even though I'm ready to do so. But like modern explanation, so let's just talk about it for a little bit. So the modern explanation is that, well, how they say it, an additional unknown acceleration mechanism is present, all right? Likely it relates to magnetic fields. This could be like magnetic switchbacks, these things, right, discovered by Parker. These are, by the way, current sheets. So where you see the sudden change in magnetic field, there must be a current somewhere in between this change. So well, you see there are these zigzags. It means like there are some currents flowing kind of in perpendicular direction here. Of course, it's forbidden to talk about this in modern like heliophysics, but these are currents. Okay. Yeah. So one of the mechanisms is, for example, proposed mechanisms is damping of Alfvén waves, right? So Alfvén waves carry, these are waves of plasma, basically kind of like this actually, so like some sort of kind of like vibration of magnetic field line, kind of like a string. You may think about it like this, even though it's a very simplified description, but it's kind of like this. These are Alfvén waves, okay? So they carry some energy, and this energy might dissipate, and that might heat the solar wind and accelerate it, okay? That's one idea. Kind of like the modern, most plausible explanation from mainstream in air quotes. Then there are other alternative mechanisms. There is, for example, the Dreiser mechanism, which is relies on electrostatic field. Okay, so but it's not as simple as you may think. So we have so-called ambipolar diffusion around the sun, which means like the sun is pretty strong, has a pretty strong gravitational field, right? So if you take a mixture of protons and electrons, so hydrogen plasma, so the protons and electrons have the same temperature, so the same kinetic energy. Since protons are very heavy compared to electrons, they cannot go out as fast, right? So imagine these are protons. So they kind of sink deeper in the solar gravitational field, whereas electrons can lift themselves up at the same temperature a bit higher. And what does that creates an outwards electric field, right? So the protons will be attracted to these extra electrons on the outside. And via the so-called Dreiser effect, where was it? Yeah, this electric field, it might actually produce these runaway electrons, as they call them, or Strahl electrons, non-thermal electrons. And these non-thermal electrons are kind of very fast. They go outside and create even more electrons on the outside. And these extra electrons attract protons once more. and that's what accelerates the solar wind according to this mechanism. Okay, this is kind of a hypothesis, but it's a good one if you ask me. Then, very recently, there was another idea by Akasofu, a very well-known guy in like magnetospheric research. So he has proposed that it's the Alfvén unipolar current that acts on the solar winds, and solar wind is charged particles, right? We have this, the magnetic field can act on a moving charged particle with certain force, and that's what he believes is happening. And according to his, so what do I mean by unipolar current? Well, there should be, since the sun is magnetized, it's a conductor, and it rotates, spins, there must be like a potential difference at different latitudes of the sun, and this drives this current, like a heliospheric wide current. I mean, we know the equatorial component, we know it as a current sheet, all right? But the polar component, that's a better question, like where does it go to? And we know it's there, it's not a hypothesis. It has been measured that it's of the order of giga amperes, right? Where is it? Yeah, something like this. So according to this hypothesis, it's this other branch where these two connect, the current sheet and the polar return currents. This downward branch is creating a net outwards force on the solar wind. So that's another hypothesis of how solar wind can be accelerated. Yeah, well, I guess that will be all. But so yeah, returning to coronal holes, it's just open magnetic field lines. That's why you get faster wind. Why the wind is accelerated in the first place? That's a great question. But once again, not much is well known here again. There are certain hypotheses, just as I've described. Okay.